So, yeah, the title of the talk is Private Computing on Public Blockchains. This is a presentation I did for Algorand. Every time you see the word, for most of the time, when you see Algorand, basically it's talk about potentially any L1, except that for what I'm going to present, Algorand is the protocol itself, not the company. The protocol is better positioned to deliver what I'm going to tell you about. But except for one point that I will say is specific to Algorand, the rest is really for any L1 in principle, and the techniques that I'm showing can be applied in other chains too. So is Algorand, and this is again for most L1s, is it scalable? It is scalable in a sense that when the network or the chain grows, the performance will be similar to, I mean, let's say with 10,000 nodes or with 1 million nodes, the performance will be the same. And the reason is that Algorand uses this idea of choosing subcommittees, which are their size is independent of the total number of nodes. So the work is proportional to the size of the committees, and the size of the committees is independent of the total number of nodes in the network. Is it decentralized? Yes, in the sense that the protocol allows you for decentralization for different properties. I will not get into that. No, I'm saying it's more decentralizable than decentralized, because Algorand right now is a small, relatively small network of nodes, and you cannot say that at this point it's decentralized, but the point is that the protocol allows you to decentralize the network as we go and increase in size and distribute the stake in more parties. Is it secure? Again, yes, in the sense of the consensus being secure, in the sense of allowing for distribution of stake as much as you want, etc. Now, is it private? So the answer is no, it's not private. I mean, all these blockchains gives you some level of pseudonymity, which means that you don't have names of people in the network in general. You have accounts, but these accounts are traceable. And if I know anything about someone with one transaction, I can trace it to other transactions. So again, no L1, except for very specific designs like Zcash, L1 networks these days are not private. But this is not just by accident. Actually, blockchains are non-private by definition. The most important thing that we want from them is to be transparent, which is the opposite of privacy, and also immutably so. So you cannot even change that. You cannot change your mind about what's there. So, right, and that's a great thing. We want everything to be there. That's the main thing we want from blockchains. I mean, of course, we want consensus, etc. But that's an essential property. And that means that, for example, smart contracts cannot carry private keys, secret keys inside them. You could have encrypted data inside the smart contract, but the smart contract cannot decrypt that information. What a smart contract cannot say is, hey, here is a secret signature key. Please use to sign these messages if the smart contract logic is satisfied. Okay, by the way, each time you see SC, that's shortening for smart contract. So again, smart contract cannot carry the key and decide what to do with that key, because that key would be shown to everyone. But we hear all the time that we can make a blockchain private, for example, with zero knowledge proofs. And that's true, but for very specific things. I mean, you can, in principle, build a private blockchain completely based on zero knowledge proofs. This will not be completely true. You need some other stuff. But what zero knowledge proofs do is to prove statements. For example, that my balance is about some limit, that I own or can prove the output of some Bitcoin transaction, that I'm allowed to do some operation because I am 21 or older, etc. But while proving the things without showing any additional, without leaking any additional information. Many times people use zero knowledge in what actually is more like a snark, where it's the operation, the functionality that you get is verification of computation and not necessarily private. So many times people will use zero knowledge when actually they are not providing privacy. So here are some examples of things we would like a smart contract to do, and we cannot actually, because we cannot carry keys. So for example, if we had a smart contract, let me go to this one. Okay, no. I'm here I have an issue with the question of animation. So it would be great if we had a smart contract that carries, this is a kind of toy example, but it's representative of many applications. Let's say that I want to carry in the smart contract an encrypted will, and only when I get an oracle telling me that that person for the will is for has died, then I will disclose the will to the heirs of this person, and only to them. Okay. We cannot do that. We cannot do that. The encrypted will be inside the smart contract, but where is the key to decrypt that? Another example is a smart contract, say running in Algorand, that wants to sign Bitcoin transactions. Okay? In principle, there is no reason not to want to do that. But again, we cannot do that because the smart contract cannot contain that wallet key in its belly. More generally, moving the signature that moves from account A, account B, where accounts A and B can be in different chains. It would be, if we had that easily, it would be great. So in the first case, the example of the will, that's an example of running general purpose private contracts. Okay, I mean, the will is just one example of a contract. In the second example, actually, that second example is very interesting because we know that Bitcoin don't have smart contracts, but what about running a smart contract that applies to Bitcoin, but running it on Algorand, okay, on some other L1? If we allow smart contracts to carry signature keys in their belly and be able to do the signature, then that's it. Now Bitcoin has smart contracts, and for us in Algorand, even better. They will be run on Algorand. That would be amazing. And not only Bitcoin, it would also run Ethereum smart contracts. We know that Ethereum is expensive, Ethereum is slow. Run the smart contracts on Algorand and apply the output to transactions and information on Ethereum. And you can run many other things. If you can run multi-signatures, different accounts, different chains, you could have a very nice social recovery run, let's say in Algorand, but social recovery for any chain. So can we do the things? And the answer is yes, we can. I'm not going to show you how we're doing in these 20 minutes, but just here I'm talking about the applications of what can be done. So some more specific examples that till now I show you. I told you more general things. So take the example of a state proof. What is a state proof? And now I'm talking about state proofs the way they are now run on Algorand. Again, the things can be done in other chains. So in the case of Algorand, we have now every 250 blocks, we give a compact proof that can verify all these blocks in a relatively efficient proof, instead of having to ingest all these blocks and apply the internal logic of Algorand. Of Algorand, for example, if you are running something in Ethereum and need to check a block on Algorand, these state proofs simplify things significantly. So these state proofs are more efficient than ingesting and checking 250 blocks, but it's still not so simple. And the other thing is that in order to check the current 250 blocks or the last 250 blocks, I need to have checked all the state proofs since the first state proof. Again, it is much more efficient than a simple oracle and gives significant power, but is not as having a very simple oracle that tells you this transaction existed at that point, here is the signature, and now you believe it. So what we can do with these schemes, which, by the way, when I say we can do this, and I'm not going to show you how, it really doesn't matter. Of course, if you're interested in the technicalities, it matters. But and all of I'm saying is, once you have the capability of carrying secret keys inside a smart contract, then you can do all of these things. So, for example, with what we are doing, we are actually building an oracle that from Algorand that will sign statements. I mean, everyone in the world will know the public key of Algorand is with one public key, and we will sign statements related to the chain for any things that consensus can agree on. So you will ask, was that transaction done? That money moved from account A to account B. I will, without you having to check anything, I will just output a signature on this transaction under that public key, and anyone that sees that knows that this answer is as trustable as Algorand consensus itself. In other words, the only way to break this system is to break the consensus. Okay, and queries can range from individual transactions to any system of. This would give you very simplified and secure bridges. You know what is called trustless, which is a synonym of saying as secure as the underlying consensus. And many more applications. For example, you can have a secret smart contract that carries encrypted medical data, okay? And it has a policy of when and to whom to decrypt some of this data, okay? So here, the smart contract, the transparent part of it, works as the policy or logic for these operations, but then in this case, let's say you want to decrypt some of the data for a particular physician, and these type of physicians get that type of data, then you decrypt it, but you don't decrypt it into the blockchain, you decrypt it into a key that that physician can actually decrypt and not anyone else. It can allow you to do tunable privacy. Tunable privacy means, when we want to have regulations with auditing and all kind of rules that you have to keep, if you want to do, bank currency or stuff like that, you can actually say, okay, only in the case that such authority asks for something, then I will decrypt it. Otherwise, I will not. You can use this to create cryptography for the end user. You can build decentralized social networks, messaging systems, and stuff like that. You can do user-protected storage, backup wallets, etc. And all of these things will be as secure as the again as the consensus. Let's say in this case of Algorand, and trustless randomness beacon, auctions, voting, even defenses against MEV, and anything that your imagination allows for.